Well, good morning, everyone, and welcome back to another exciting day of mathematics. Whoop, whoop. How's everybody doing? Good? Day 4. My goodness, it's flying by, right? Time flies when you're having Algebra 2. All right, so warm-up number 4 is on the screen. Copy that, and then I'm going to give you a code to log on to Nearpod so we can communicate it here in class. So get your Chromebooks ready as well. I'll give you time for that. Copy and go. And by the way, FYI BTW, notice at the bottom left of the screen, it says recording. Some of you are going to be immortalized in my video that's going up on YouTube. Upload the video probably after lunch so you can have it available in case you need to revisit the lesson. Okay? Thank you, Mr. Q. You're welcome. All right. All right, just to read the warm-up, it reads, find the sum difference product and quotient of negative 15 and 23 microjoules. Let's go. You guys don't know anything about that. Number 2, find the sum difference product and quotient of negative 7.7 and 2.3. And for number 3, just get your Cornell notes ready. However, to get this show on the road, share with neighbor what you got for number 1 and number 2. Really quick, before I start out calling on people, number 1 and number 2, share with your neighbor what you get. Number 1. For number 1, I just want, let's see, make it easy on this one. Let's do the quotient. Quotient for number 1, negative 15 and 23. Quotient, what you get for the quotient? Kelly, pick someone. Quotient. Negative 0.75 or negative 3.75, you said? Oh, my bad. Sorry. Oh, 652. 652. Hands, if you got something close to that? Looks about right. Let's go. Oh, yeah, we got this. Number 2, before we pass that to someone, tell your neighbor what you got for the difference of negative 7.7 and 2.3. Share with your neighbor. Negative 7.7 and 2.3 before we pass that to someone. All right, negative 7.7, difference means subtract 2.3. Let's see, this is a tricky one. Let's see how we did. Caitlin, pass someone. Kenyon, what'd you get? 5.4, close. Let's see. Negative 10. Hands have got negative 10. Yeah, that is correct. So like I said, this one's a tricky one. This negative attaches to this number, and since both of them are negative, you combine them, negative 7.7 and negative 2.3, that's negative 10. We'll get there today. We're going to explain some of those in today's session. All right, thank you guys. Make sure you get this ready, and let me send you the screen so you can send me your notes for that warm-up. Let's see what you did. There it is. Send it in, please. You're sending that in. Let's see. How are we doing with the process? We walk in. We started with the what? Warm up. From there we went to what? What are we going to next? Tell your neighbor. What would be the very next thing? Very good. Copy the agenda. Copy that, please. Agenda for today. We did warm up number 4. Today we're going to start with number sets and expressions. From there I'm going to leave you 6 problems for your home play just on expressions. And we're done. Let's see if we can get through this lesson. Like I said, we're still getting used to using Nearpod and the note process that we started for this week. Okay? Little by little. So once again, we started with a warm-up, went to the agenda, you copy that. Now, since you do need to do your home play and you need access to the presentation for the problems that I'm going to give you, I'm going to give you a code for you to write down when you get home, log into Nearpod. That'll give you access to the home play, yes? And it looks like this. There it is. Write that down. HZDER. HZDER. So when you get home, log on to Nearpod. You're going to see exactly what we did right now. You're going to see the warm-up, the agenda, this screen, but then you're going to see the next screen where it shows the home plate. So make sure you go to that screen of the home plate, do the home plate, don't turn it in on the Nearpod, bring it with you on your paper so that we can go over it tomorrow. Does that make sense? All right. We good? All right. So, with that said, from there, I would check your home plate, but did I leave you home plate yesterday? No. Just really quick, just to reiterate, what materials do you need for this class? Well, you need a notebook or in a section in your binder for this class, pencil, highlighters. I'm going to be using 4 different colors once again so you can see some of the differences in math or the skill. And you can buy those 4 colored pens. They have them at any dollar store, Keith Bargain down the street. And we're going to talk about the textbook as soon as next week comes around because I still have some schedule changes going on. Okay? All right. So last night I said have a great day. Everybody had a great day once you left here, yes? All right, good. Everybody was off their cell phones and stuff, yeah? You're like, Mr. Q, I got home and I washed cars and I cleaned the house. Ooh, that's good. My goodness. That's your home plate for tonight. Woo-hoo-hoo-hoo-hoo. However, you have the code to access that, yes? All right, Cornell note, copy the objective at the bottom left. I can simplify algebraic expressions. I can simplify algebraic expressions. I can simplify algebraic expressions. Now, the reason I'm emphasizing and simplifying is because there's something particular about expressions in regards to that, and we'll talk about it in a little bit. However, I can simplify algebraic expressions. If I ask you the question, what is the main concept for today? Tell your neighbor what would be the main concept for today. Main concept for today. Main concept for today is algebraic expressions. That is correct. What are we going to do with them? Simplify. That is correct. Today I'm going to take you back in time, guys, because I want to make sure that we have all the foundational stuff before we even get started with our Algebra 2 material. So I'm taking you back to elementary school. Some of you saw this kind of math that we're going to see today in 4th, 5th grade. Then again in middle school in 7th, 8th, and 9th. Once you got over here in Algebra 1, geometry, you've been seeing this kind of math. But I just want to go over it with you to make sure that we're on the same channel. Okay? All right. So with that said, you wrote that at the bottom left. And we are going to focus on algebraic expressions, but let me do first a review of stuff that you need before we get there, okay? So with that said, y'all ready? Writing utensils down, look up to the screen. Let me pause the tunes in the back really quick. Here it goes. Before we get to expressions, our mathematical journey starts with numbers, okay? And I want to break it down to even to the smallest portion, and but there's one thing that I want you to understand in regards to expressions, because this is one confusion that a lot of you had last year or the previous years when you guys were actually simplifying expressions and solving equations. Some of you didn't know the difference one to the other. I'm going to explain it. I'm going to break it down. Ready? We cannot solve expressions. Let's hear that clear. We cannot solve expressions. There's only 3 things we can do. You're paying attention, you're not taking notes. Here it goes. What can we do? We can translate them, we can evaluate them, and we can simplify them. Can we solve them? No! We can only do all those things. So for example, let me give you an expression. Ready? Here it goes. Expression. A number minus 23. Saw that done? Pretty good. It reads, a number minus 23. That's an expression. They're just expressing an amount. So what can I do? Can I translate that? Yes, Mr. Q. Can you translate that for us, please? Sure, here we go. I'm going to translate it. A number. Do I know what that number is? No, I'm just going to give it a value, which means a letter. So here we go. The number that we usually use in mathematics is what? X or Y. But for the purpose for you to get out of that box, I'm going to use the value of Q. Ooh-wee. So Q represents what? A number, which we don't know what it is. What's next? Minus. Can we translate this into a number? Yes. So what I just did, I translated that expression. Straightforward? Yes? Now, to evaluate this expression, I would need to know what Q stands for. So let's say I said the letter Q stands for 100. So to evaluate, instead of writing Q, what am I going to write? 100, that is correct, minus 23. I just did what? Evaluated. What does evaluate mean? To substitute into the value of the variable. What is my last step? Simplify. I'm going to simplify. What is 100 minus 23? 77. Did I solve anything? No. All I did is make the expression, gave it a value, and made it smaller. That's what we call simplifying an expression. Now, when we get into equations, then we have to do stuff to both sides and a bunch of stuff. That's something else. Okay? All right. Good review. Move forward. Copy this on your underneath your Freyer model, please. You see, you have your Freyer model, the other one that you did, right? Copy this one underneath, because we're going to go over numbers really quick. Copy that table, please. Yeah. Once again, once you have your table, top left, you label it real numbers, right side imaginary numbers, and the bottom complex numbers. I'll give you some time to set up. Go. Okay, we good? All right, so check this out. Look up to the screen. Right now, I'm going to focus only on real numbers, real numbers. I'm going to go piece by piece so that you guys can see how your evolution in mathematics from elementary school to right now, how it went and how it's going, where we're headed. Okay, here it goes. Let me pause the music in the back. Y'all ready? Okay, writing utensils down, look up to the screen. Once again, if you fall behind with the notes, you have the code now for the presentation that you can catch up at home. Okay, here it goes. Look up. Look up. Real numbers. Real numbers have two subsets of numbers in there. What are they, Mr. Q? Well, they're divided into rational numbers and irrational numbers. Don't write this down, you're just paying attention. What's the difference between one to the other? And reminder, I'm still recording. Those of you with your mobile devices, put those away. My goodness. Stay focused. Here it goes. What's the difference between rational and irrational, Mr. Q? Rational numbers, pay attention, rational numbers can be expressed as fractions or decimals. As what? Fractions or decimals. So rationals are what? Fractions or decimals. Rationals are fractions or decimals, or expressed like that. But within there's certain groups that you started with. So let me take you back to preschool and kindergarten. Your teacher had you make, had your nap, right? Remember nap time? Let's go. Then your little milk and cookie. Then from there they had us go out into the yard. What did you do? You ran to the swings, right? And then you sat on the swing. You wanted to race someone. And what did you start doing? You're like, ready? Let's race. -1? No. What did we start with? Counting numbers. That's the first set of numbers that all of us start with. Counting numbers. Those are known as real numbers, and they are under rationals. Check this out. 1, 2, and 3. Question. Can I make any of those numbers a fraction? Think about it. Yes, Mr. Q, dividing it by 1. What is 1 over 1? What is 2 over 1? 2. 3 over 1? 3. Any of those can be expressed as a fraction. Okay. From there, you evolve to 4th and 5th grade. And then in 4th and 5th grade, you went to whole numbers. What were whole numbers? Counting numbers, including 0. You're mobile? I'm sorry? Oh, you're writing it down? Okay, yeah, don't write anything down. You're paying attention. Do you see the difference? Counting numbers have 1, 2, 3, but now it has what? A 0. That's when you were introduced 4th, 5th, and 6th grade. But from there, once you get to 5th and 6th grade, your teacher said, okay, now guys, think about the same numbers, but now we're going to talk about their inverse or their opposites. And what did that include? All the negatives, right? So that's when we talked about integers. And all of these can be written as fractions. What is 0 over 1? 0. What is 1 over 1? 1, and so on and so forth. So far, so good? All right, copy this, please, really quick under that, the real numbers. All right. So far, how are we doing with our going back in time? Not bad, yes? All right, so here we go. Second portion, irrational numbers. Okay, writing utensils down, look up to the screen. You'll finish copying in a little bit. Look up. So real numbers have two groups, rational. We said that those can be written as fractions. So what do you think irrational are? If these can be written as fractions, guess what? These can't be written as fractions. I'm going to give you 4 examples. Pi, square root of 2, phi, and e. We're going in that direction towards the end of the school year. You'll know what those are, but for right now, just copy those 4 on irrational numbers. Those cannot be expressed as fractions. Those cannot be expressed as fractions. And once again, so that you remember what this one is, put like a 1/2 right here and 0.75. So rationals can be expressed as fractions or decimals. Fractions or decimals. Irrationals cannot. And once again, all of these are real numbers. Now here goes a side note. I'm going to write it over here on the side. Square root of 16. Think about that one. Square root of 16. Now, maybe some of you forgot what that means. This is what it means. Y'all ready? Here we go. Square root means what number times itself gives us this number inside. So think about it. What number times itself? What number times itself gives us that number? Tell your neighbor, what's that number? What's the number times itself that gives us that number? Who's got it? Everyone? What's that number? 4. 4 times 4. However, there is another number times itself that gives us that number. You're like, what? Yeah. -4 times -4. What is negative times a negative? Positive 16. Positive 16. So that means this one falls under which category? Yeah, integers, because it's positive 4 and what? -4. So far, so good? All right. So, real numbers, got it. Let's go into the funner ones. Y'all ready? Imaginary. Ha, 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 ha. Ha, 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 ha. And we're going to be covering this once we get to the semester. So write down square root of negative 16. Square root of negative 16. All right? Let's do this one together. What number times itself gives us negative 16? Think about it. What number times itself? Tell your neighbor, what do you think it is? What number times itself? Like Giovanni's got it. Very good, Giovanni. I see you. Looks like Abigail's got it. Very good, Abigail. All right, let's see. Go with Gabriel. What did you guys talk about, Gabriel? It's not possible. Wow, let's see. How about 4 times 4? No, that's positive. Negative 4 times negative 4? No, it's positive. Can I switch a positive and negative? No, the rule is what? A number times itself. So there's no such number. That's why there's no real number that gives us this. But can I do mathemagic to change this? Yes, write this down. Negative 16 becomes square root of negative 1 times positive 16. Do you agree with that so far? Yeah? So now that I got 2 factors inside, I'm going to split this big square root into 2. Square root of negative 1 times square root of 16. Now check this out. What is square root of 16? 4, is that correct? And we said it could be positive or negative, okay. However, we're left with this. From now on, whenever you end up with a square root of negative 1, that's what we call the letter I. What does I stand for, everyone? Am I taking you to someone? No? No. Never mind. Imaginary numbers. That is correct. So square root of negative 16 is positive negative 4i. 4i. Let's do another one. Here we go. Write me square root of negative 36 as imaginary, please. Square root of negative 36 as imaginary. All right, show your neighbor what you got, and then I'm going to call on someone. They can help me out. Show your neighbor. All right, looks like Joshua's got it. Let's see, Joshua, walk us through this. How do I rewrite this? Square root of negative 1 times 36, and that becomes square root of negative 1 times square root of 36, which becomes plus minus I. Hands, if you got that? That is correct. Let's go. Let's do another one. One more. Square root of negative 81. Square root of negative 81. See if you can go a little bit faster now. Square root of 81, negative 81. All right. Share with your neighbor what you got for that one. Square root of negative 81. What'd you get? Square root of negative 81. Joshua, pass them one. Franco, what'd you get? Plus, minus what? 9. Hands if you got that. From 1 to 5, I'll come to borrow you with real numbers and imaginary numbers. 1 being the lowest, 5 being the highest. I'll come to borrow you so far. 4, 5, 4, 5. Yeah, we're getting there. Like I said, it's stuff that we saw a long time ago, but I'm trying to put it together like a puzzle. So we got real numbers, we got imaginary numbers. Let's go to the last portion. Complex numbers. Complex numbers. Y'all ready? All right. When you pause the tunes. And this is where we're headed, guys. We're going to head in the direction of imaginary and complex numbers throughout the year. We're going to be using those, but I just want to give you the foundation. So, writing utensils down, look up to the screen. So we know what real numbers are. We know what imaginary numbers are. So what are complex numbers? And notice, everything has a purpose the way I lay out my structure. What's on the left? Real numbers. What's on the right? Imaginary. Complex has both. Let me show you one. Look up. Complex. Here it is. For complex, I take a real number from here. Let's see, somebody give me a number from there. 23, very good. Is that a real number? Yes? Yeah, okay. How about a imaginary number? I'm going to do plus, I could say minus or plus minus, plus 4i. Write that down. This is a complex number. Comma. If I wanted to write with a negative I, it would be what? 23 minus 4i. So what can we concur? That complex numbers has what? A real number and an imaginary number. So here goes another one. Let's see. Give me another one. Franco, pass on one. Oh. I can't hear. Oh, go ahead. 60. 9i. Okay, hands if you agree that that's a complex. Yes. And on the negative side, it's 60 minus 9i. Okay. Therefore, I want you to give me two more complex numbers there, please. And then after you do that, I'm going to send you the screen so you can send me your table to make sure that you took copious notes. It's on your screen, please. Send me that. Next section. So, good introduction, Mr. Q. Thank you for real numbers and imaginary and complex. So far, so good. Yes, where we're headed. All right, let's move on. Let's talk about some properties that we've been using so far from the beginning of the school year. Don't copy this. Writing utensils down. Look up to the screen. The first one's called the additive inverse property. I've been giving you to add and subtract numbers, haven't I? That property looks like this. A number plus its opposite gives us 0. Such as 7 plus negative 7 equals to 0. If you master this property, you should be able to approach positive and negative numbers really well. And let me show you how it's done. So if I was to give you negative 15 plus 15, you know that's 0. Negative 2500 plus 2500, that's 0. However, what if I gave you this? Look up. Positive 23. And negative 20. What do I do there, Mr. Q? Well, check this out. You go with the smallest number. What's the smallest number? This one. And you ask yourself, can I cancel 20 of those over here? Yes, 20 of the negatives cancel 20 of the positive, and that leaves us with what? 3 positives. On the same token, if I was to give you, another 30. Hold on. If I was to give you 30 plus negative 35, same idea. Go with the smallest number. Don't worry about the sign. Smallest number is this one. Can 30 of these cancel 30 of those? Yes, and that leaves us with what? Negative 5. And so on and so forth. And what property am I using there aside from just the zero pairs? This next one is the identity property, which is what I just showed you. All that is coming into play. Now, we still haven't gone to algebraic expressions, but let me explain numerical expressions. Look up. Numerical expressions, self-explanatory. 3 plus 5. 2 minus 6. 4 times 7. 8 divided by 4. What do you guys notice? They're just numbers, but what else do they have? Operations. Plus, minus, multiplication, and division, but only numbers, yes? All right? So, we went from numbers, now I'm transferring to numerical expressions, and now we're going to get into algebraic expressions. Y'all ready? All right. Let's go to our notes. Here we go. I can simplify algebraic expressions. In here, write algebraic expressions. Algebraic expressions. I can simplify algebraic expressions. So now we did a very good intro with numbers. We're transferring over now to expressions. And mind you, we still have not gotten to equations. We still have not gotten to equations. Okay, we're still in expressions. Definition, here we go. What are algebraic expressions, Mr. Q? They are expressions that contain variables, constants, which means just numbers, and operations. Algebraic expressions are expressions that contain variables, constants, which is just numbers, and operations. And this is what they look for. X plus 3, m minus 7, 2 times y, k divided by 5. So once again, algebraic expressions, that's our main idea for today. What are they? They are expressions, and they contain what? Variables. Let's see, do all of these have variables? Yes. Do they have numbers? Yes. Do they have operations? Yes. So far, so good? Now, what is a non-example? What don't they look like? Look up, please. These are examples. These are not examples. Ready? Don't copy them. Look at them. Trying to be very obvious to make sure that you see expressions and what they are by themselves. Tell your neighbor why these are not expressions. Why are these not expressions? Does everybody see it? Does everybody see that these non-examples have what? Equal signs or inequalities. We're still not there. So therefore, over here, what makes algebraic expressions algebraic expressions? So as you're copying this, I'm going to put some hashtags in here. So if you were to get home, send the notes to someone with a little picture and do a hashtag. Hashtag, what makes an algebraic expression an algebraic expression compared to this? That it doesn't have what? Does not have what? Doesn't have what? Yeah, equal sign. Or some of these. Hashtag, what does it have? variables, comma, I'm going to put a hashtag with an S for numbers, comma, operations. This is what makes algebraic expressions algebraic expressions. Pretty good, pretty good, yes? All right, so send me your notes to make sure you filled out your Freire model. Let's see what it looks like. All right. So now that I introduced algebraic expressions, let's go over some examples. I'm going to do only one or two examples if we get to the second example, but this is just a review, like I said. You can log out of Nearpart as soon as you send your Freire model. Write on your paper, example Q. Here we go. I'm going to start first with a numeric expression. Numeric expression. 4 plus negative 2 plus 5. Write that down. First step, I'm going to combine all the positives and all the negatives. So first go with the positives. We got 4 and 5, I'm sorry. This becomes what? 9. Bring down the negative. Question, which is the smallest number? Because they're opposites, the 2. Can 2 of these cancel 2 of these? Yes, and that leaves us with what? 7 positive. That is correct. Go to example super Q. 4x plus negative 2y plus 5x plus negative 6y. Combine all the x's first, and then from there go to the y's. 4x and 5x become what? 9x. Write that down. Next, combine all the y's. Negative 2y and negative 6y is negative 8y. And what's in between everything? Addition. So make sure you put a plus sign between those two. Since x is not the same as y, we can't do anything else, and we are done. That's going to be your home plate. Now, I did include like one that has a squared, x squared, just to see how well you remember from these past years. We'll stop right there. I'm going to upload the video right after lunch, so make sure if you want to revisit the lesson, go to my YouTube channel, 23 MRQ. Make sure you subscribe, share, like, and all the stuff, yes? And the home plate, you have the code. Have a good one, guys. Enjoy your home plate. See you guys, Molly. Bye. Have a good one.